I'm Adrian, and I'm going to talk about systemtap and how you can use it to do fun and questionable things. So just a word about me. I'm French and freelance, and I like low-level stuff, debuggers, kernel stuff, and playing with the libc and things like that. So I ended up playing a lot with systemtap for the last 2 years or so. And so that's how I came to think how to use it for doing interesting potentially security-related stuff. I'm not a developer myself. Well, I can write code, but I'm not really a developer. And I'm just a systemtap user. And I'm not a VRFH either. That's probably because I don't really have users. But, I co-founded the free software user group on me. Please go. No, yeah, well, if you live in the Arlon area in Belgium, you probably want to check them out. It's a good place for technical meetings. Yeah, I'm looking for a job.
Sorry, we are full, guys. I think we are full.
Okay.
Way too much.
So, the bastard operator from L, so the VOFH is the bastard operator from L. It's a supposedly fictional character. Yeah, we would just enjoy abusing its users. So, yeah, if you the typical story is like the user calling the admin I don't have any more space in my home directory. So yeah, okay, I can fix that. And here I can do home directory for you and the backup as well, so you don't have to worry about free space anymore. And yeah, that's how the bastard operator from L will help users, just deleting their files. But we'll see some more subtle ways to allow users and how the bastard operator from L can use systemtap. So systemtap is, if you look at the website, you have a nice description explaining how systemtap is a useful debugging and tracing tool that will help you to figure out both functional and performance issues. But really, I like to think of it as like a system-wide code injection framework. So yeah, if you start to think of it like that, that makes things interesting. But yeah, basically you can just say anywhere in the system I want this thing, I want to see what's happening just there. Or you can also say I want to actually change all this part of the code here at any point in the system, be it kernel or application or library or whatever. And you don't have to rebuild the whole application or the whole kernel or reboot anything. So yeah, that's a pretty powerful debugging tool. We'll see a bit more details about this. So this presentation specifically is about the VRFH, finding a new toy in systemtap. And we see how the VRFH can use systemtap to do things, to do interesting things. We're not, yeah, this is the security level, but this is not actually really breaking any security because the VRFH is root already, and we are not crossing trust boundary or anything. Everything we are going to do here, you can already do it with the root privileges. So you don't really need systemtap for that. But systemtap makes things much easier. And we'll see some example of that. So yeah, there are two parts really. I'll start explaining systemtap and see what it can do. And then we'll see some example with demos if I can manage to make them more. Questions so far? Or? So systemtap works in what it does really is you write a systemtap script in a specific language, and there's the step binary that converts that into C, and the C is compiled into a kernel module, and the module is loaded, and step communicates with the module if it needs to. So in practice, you end up with something like this. We run step with -d, so we can see actually what happens. So yeah, the script is parsed and analyzed, and then it's translated into a temporary C file and with a nice name. And it's compiled into a kernel module that's loaded, and if your script is actually doing some output, that would go there, and you would just add it there. That should be pretty obvious and boring. So systemtap is all about looking into certain things. So we want to probe specific parts of the system. So this is all about executing certain actions when something happens. So that's where the place where we want to execute the action. It's called a probe point, and so probe points. There are some examples of probe points, so you can get an idea of where you can tap into the system. So, for example, you say whenever there's a real system call starting, we are going to do something, or whenever we are returning from a closed system call, or you can use wildcard and say whenever we are entering any function in the floppy module, or you can say whenever we are returning from any function in the socket.c file in the kernel, or whenever we are hitting line 2917 in the scheduler. Some more examples, you can also say every 200 milliseconds let's do something, or whenever, well, it's not restricted to kernel as well. You can say whenever we are whenever we're entering any function in ls, or whenever we are entering any function that has malloc in its name in the libc, we can do something. Or you can combine it with collab and say whenever we are entering any function in the kernel that has init in the name, or whenever we are returning from any function that has exit in the name, and that would be a single, but that will be aggregated as a probe point in the script. If you get into systemtap, just click the friendly manual, and you will have much more details about all the probes that are available. But that should give you an idea of what you can tap into. So the systemtap programming language is kind of C, kind of Oak, because obviously you are we're executing actions whenever we are hitting something. That's pretty Oak style. There are many facilities built in. I'm not going to go too much in details in this presentation about that, but you have associative arrays, you have aggregate of statistical data. That's pretty useful if you do profiling, but we are not talking about that today. And there are many helper functions, both built in within the language and available as libraries. That's called tap sets. That's really systemtap scripts that are reusable from the kernel. And but if you want the full details, go and read the manual. So some example of helper function to give you an idea again. I think most of these are pretty obvious. Give the PID, so we know what process we are in, what thread we are in, what is the name of the current process. Probe function, maybe you can do it a little bit. As you have seen, we can use wildcards, and so when we give one probe point, that will really match multiple probe points, and we can end up in any of multiple functions. In that case, probe function will tell you which function we are in. Print factor is pretty useful when you're at the beginning stuff, so you can figure out how we ended up there. And the BFH is probably more interested in things like kernel string and user string to, you give it a pointer and it will get the string of that address and convert it into something usable within systemtap in a safe way that you are not like different some things that you shouldn't. Well, you probably shouldn't reference it, but it will not track the system. Yeah. And again, there are many more. But that's just example to give you an idea. Questions so far?
Show some nice example.
Yeah, the examples are coming. But I think you need to have some idea of what the example are. Well, you need this to understand the example. Yeah, some more step options. So you have by default, if you run a step script, that will just trace everything on the system. If you say -x, you will trace just the specific PID you want. -c, so you can run just specific process. Something we'll see uppercase L, so you can that will not run any script. That's you give it a probe point, and it will tell you what variables are available at that probe point. And if you say wildcard, it will expand the wildcard and tell you what you are going to match. So that's useful when you develop systemtap script. Uppercase F is nice to so the stack will just load the module and then it will quit, but the module will still be loaded. So you won't have I/O, but the module will do what you want it to do, and it's more stilty because you don't have a process hanging around. So yeah, the WFH is probably interested into that. And you have the -G, which lets you, by default, systemtap will not allow you to change anything. It will just allow you to trace things and observe things. -G allow you to change things and to actually inject C code, so well, you can do really whatever you like. Of course, that's very easy to crash process and system if you change the behavior of the system at runtime like that. That's fun. So, questions before the example? The interesting part. So, let's see how we can apply this. So, this is an example. You may know maybe libpurple. It's something that's been developed for Pitkin, and basically it's a library to. It's an IM library, so you can talk with your friends on ICQ or IRC or Jabber or whatever through libpurple, and well, the application doesn't have to care about the protocol. libpurple handles that, and every communication basically goes through that function in libpurple. So purple conversation, right, with some arguments. I have no idea how most of these what they are for, but the who and message are probably interesting. It's obviously the person sending the message and the actual message. So we can use systemtap here to actually tap into the library libpurple and instrument the specific function, purple conversation right. And when we are in this function, we just say, we retrieve the sender of the message, actual message, and we just print it. And yeah, I didn't have time to get the internet on my laptop, so I cannot really demo this one. I can show you at the end if we have time. But
how do you get the who and message variables? How does it know that those are the second and third variables?
Okay, that's because you have the debug symbols for that.
Oh, I see. Okay.
So yeah, it uses the debug symbols. You don't necessarily need debug symbols installed on the machine you are going to instrument, but you need them at some point when you build the systemtap module. I can give you more details about that if you like, but I have just a short time. So yeah, I cannot demo this one because I don't have internet. it works and it so this one, yeah, I'm probably going to skip this one because it's not so interesting, and I don't have time. But this one is more interesting, I think. So you have, let's say you are the BioFH and you want, you don't like your user to play MP3 files for whatever reason. So there's that function in the kernel called mayopen, and that function you give it a path strict, yeah, and the kernel determines if that user have access or not, and so the mayopen function returns 0 if the user is allowed to access the file or something else otherwise. So what we can do, so if you look at what systemtap will see for the mayopen function here, we are going to instrument the return of that function. And so you see here the variables that are available. That's using the debugging tools. And you see, so what we can see and check from systemtap at that point are well, the return value, obviously, the path. We're probably interested into that. The rest are, yeah, well, there are more things you can look into if you're interested in, but most of them have no idea what they are. So the systemtap script we're going to write to provide is, you are just going to say, we're instrumenting when that function is going to return, and well, okay, when that function returns, we look if we're going to let root do whatever it likes, so it's easier. Well, we are root after all, so yeah, if we are not root and we are not already disallowing access to the file because the return value is 0, and if in the path of MP3, so this dname and is in STR are systemtap provided functions. So dname will so here we are the path strict. We look into the D entry and we get the actual name of the file, and is in STR is like to look at if MP3 exists in that file name. And if it's the case, well, we replace the return value with -30 to say permission denied. But you can give another error code if you like. If you like to confuse users even more, you can say so I should be able to kill the name of this.
Okay.
Okay, so we have the systemtap script running there. And we are a user. And well, the thing is, we are instrumenting the mayopen function, but we can still create files. So this works, but this won't. And you see, we have to write some stuff.
Is it possible for the user to rename the file?
Yes, the user is still able to work around this, of course, because, well, you are just instrumenting the mayopen system, but so you can still, use rename, and yeah, you can say, oh, it's really OGG file or whatever. But, well, it's just an example.
What distros have systemtap by default installed?
By default, you have Fedora and all the Red Hat-based distribution, the recent ones.
So are you saying that by default there's the toolkit or rootkit on all those?
Yeah,
It's just
yes.
already installed and
Yeah,
every access.
Yeah, if you are good, you can do this kind of stuff pretty easily on Fedora, on all Red Hat-based system, and on the next stable Debian, and probably others. I don't know. I think Gentoo. Gentoo, I'm not sure. Ubuntu, for example. You check it out. Check the state of systemtap on your distribution.
What about debugging symbols?
What about, sorry?
Debugging symbols on a normal.
Yes, you need the debug symbols for what you're instrumenting at some point. So for the kernel, you are going to need the debug info for the kernel. That's usually shipped as another package along your regular kernel in most distributions. So yeah, your distribution needs to have prepared for that, or you can rebuild your own kernel. But do people still rebuild their kernel? Another example, unless there are more questions.
Is there any performance degradation because of this?
Well, depending what you're doing, yeah. For the example with mayopen, you are not going to notice anything. I mean, that's just one function. You are just going to you have a simple condition. I mean, yeah, you are referencing a pointer a couple of times, doing a string comparison, and yeah, checking the UID and the return and a value you already have in your register. This is not going to cost you any time. Now, if you do more complex stuff, yeah, but that really depends what you're doing.
If you don't do any complex stuff in your functions, but you're just trying to plug into a lot of the kernel functions.
Yeah, if you are going to plug into a lot of things that are going to be called a lot, you may have problems. There are built-in safeties. I'm not going to detail here. But basically, if systemtap notice that it's just going to be too costly, or it's taking more time doing that stuff than actually letting the kernel do whatever, it will just stop and say, okay, don't do that.
Some kernels come with custom modules that restrict this kind of rootkit to run, like some kind of patch that can be proposed and that are applied automatically on the kernel, and that is allowed, or is there no way to?
Well, there are ways to not allow that, but basically you are going to. It's actually a feature that's part of the kernel. It's basically based on key probe. So you can, when you build the kernel, you can say I disable key probes, and you will not be allowed to. Well, you will not be able to do that. Well, not as easily. But I don't see the point of a feature restricting another feature if you are already in it. I mean.
No, I was just thinking of a guy hacking my system, then installing the rootkit, and how to make sure to.
Well, if it's root,
should I run all processes encrypted or things like that?
Well, this is Unix. Once the guy have root, it's game over. You reinstall the versions and so on.
Yeah.
Yeah. The systemtap just make the things easier. You could already do that 10 years ago with your own shellcode and stuff. It's much harder. Here, you know, 5 lines of code. You can just say. Do pretty arbitrary things to the system. There are 2 questions.
Is it possible to use systemtap against C++ programs?
Yes, you can do. My example is R4C, but that works as well for C++ and no, there are things for Python and Java and Perl and other languages. Yeah. No, you were just saying 3 minutes left, and yeah, I can give a very quick example of the. That's not the most interesting one. In 3 minutes, I'm just going to say, oh, do you like systemtap with systemtap? So yeah, last time I gave this presentation, I was asked, can you hide systemtap with systemtap? And yes, actually you can. So a couple of hours later, I came up with a script that do that. So the list of modules, well, basically what you want is the module, the load. So the list of modules is stored as a list in the kernel, and you just need to move the modules around. When someone is going to look into the list, you just move the modules you don't want to show in a list somewhere, and you get it back in whenever appropriate for you. So this is the function. Here we are using it against systemtap brew because you are actually writing in C. So yeah, you look at this later because I don't have time to detail. But basically, you are using the kernel API to just mess with the list, and we are going to store the event models in a list. In a static list with these functions. And actually, how you actually use this is that in the module.c file in the kernel, you have a function called mstart that is called whenever someone tries to read proc modules, which is where smod goes to see the list of modules. And so whenever we're going to read that file, well, we inject there.
One minute.
Okay. And what we are doing here, we want to inject just after the midtext, but before we actually do anything with the list. So that's why I do +2 here. And we just call the function we have written just before to move the modules around. And we do the opposite when the user closes the file. So I don't have time for the actual demo, but yeah, basically whenever someone will open the file, it will not show the modules you are hiding. So you are hiding systemtap with systemtap. And if you want to know more about this stuff, yeah, my slides and all the examples will be online in a couple of minutes at staff.bofh.french.be. For systemtap itself, you probably want, if you are interested, look the beginner's guide on the systemtap website. There's a wiki as well. There's a lot of excellent documentation for systemtap. If you are not interested in systemtap, you are maybe interested in the bastard operator from Health Stories. And yeah, and I'm still looking. Yeah. I might not be looking for a job anymore, but maybe still.
Okay. Thank you.
Yeah, okay.